Hey everybody, today we're just going to go through somewhat of a topic that's not too bad. I think it'll be a little bit of a breather before we get into some more, a little bit more complex types of topics. So we're going to be talking today about atoms, elements, and compounds. So first of all, and this is just, it's more of definitional, and you've got to keep those definitions straight. So the first concept is an element. That's the simplest form of matter with a unique set of properties. Okay, and so we've talked about elements all along. Essentially, elements are single atoms, and so when you break it down, eventually you're going to get to, if you break things apart chemically, eventually you're going to get to an element. And of course, the elements are all of what's listed on the periodic table. This is missing some of the elements in the two rows that are down below, but other than that, this has most of the elements in this picture. Okay, and so some elements only exist as diatomic elements. Okay, and there's a really good way to remember these. These are the ones that are the most important to remember. I'm going to tell you there's 7 that you need to remember, and these only exist in pairs of 2. So let me just take a picture of this partial periodic table here, and they're missing hydrogen for some reason. They put it right here in the middle. I don't know why they did it that way, but let me just put this on our notebook. And I want to show you how you can remember all of these 7. So just we have to remember that there are 7 diatomic elements. And that means that these elements only come in pairs of 2. So when I just say there's oxygen gas, you should always know that I'm always talking about O2. Okay, diatomic meaning 2 atoms together. Now there are, again, 7 elements that are like this. And I'm going to show you one way to remember this. First of all, you have to remember that hydrogen is one of them. It only... When you talk about hydrogen gas, you're talking about H2. Okay, and then here's a good way to remember where you go from the nitrogen over here to the fluorine and then down to the iodine. Now look how it kind of looks like a 7. Okay, so you've got to remember hydrogen plus draw 7 starting with the nitrogen, and then every one of those elements, for example, nitrogen gas, when you hear about that, it's N2. Fluorine comes in form of F2, and that's how those elements come. Okay, let me go back there. Okay, now a compound now contains 2 or more different chemically combined or elements that are chemically combined in a fixed proportion. They can be broken down into simpler elements during chemical reactions. Okay, and so obviously the famous one here is H2O. There's many others: CO2, C, carbon monoxide, NaCl, all of these. Anytime you have more than one element that's combined and bonded together, you have a compound. Okay, there's and then as it mentions here, you can't separate out the elements in a compound by filtering them or by distilling them and doing all of those physical processes that we did way back when in the dirty water lab. Instead, you have to use chemical processes, which means you have to actually recombine the atoms, and we can talk about, usually it gives off heat, usually gives off smell, different things like that that chemical reactions do. All right, so here's kind of a question. Which of the following are elements, compounds, and how many atoms does each have? So we're asking, are these elements or compounds, and how many atoms does each of these have? Okay, now go ahead and take a pause for a second and look at these. Okay, and then I think that what we're going to do is make this into a question. So I'm going to ask you this question. You can go ahead and answer it. So I won't answer it on the video, but I'll have you answer it on the Edpuzzle. Actually, technically, if I give you a second, I can tell you now. I'll put the question, then you can answer it. So obviously, we have nitrogen and oxygen. They have these look a little bit funny. The way that these look, this is kind of a way of showing kind of the electron cloud around the atom. So normally, atoms will just kind of be like ball and stick sort of looking model, where the stick represents a bond and the ball represents the atom. In this case, they kind of look like maybe some balloons that are sort of pushed together. So obviously nitrogen and oxygen, those are bonded together, so that's going to be a compound. Here we just have nitrogen and nitrogen bonded together, so those are both of the same element, so we just call that an element. And of course, this is one of the diatomic elements that I just showed to you. Over here we have carbon dioxide, well known. That is definitely a compound. And then of course, chlorine and chlorine bonded together is an element. That is another one of the diatomic, meaning 2, of course, 2 atoms. Elements that always come in bonded together in pairs of 2 atoms. Okay, so compounds, the properties are different from the elements. that they are made of, okay? So this is important to understand. It's like, normally we would think, oh, okay, well, we take an oxygen and we combine it with a carbon, and then the result is going to be like a combination of those two. But the funny thing about compounds is they have totally different properties than what their elements might have. And obviously a great example, which I've used in class, is that sodium is highly poisonous. It would explode in somebody's stomach. Chlorine is a poisonous gas. When you put them together, it actually becomes a completely harmless substance that we know as table salt. So that's just a good example about how the actual compound can be very different, okay? So sugar is a sweet white solid, carbon is a tasteless black solid, hydrogen is a colorless gas, and oxygen is a colorless gas. So the point here is that sugar, the combination of these three elements down below, becomes sweet, white, and solid, but it's made up of something that's tasteless black and solid, colorless gas, and a colorless gas. So you can kind of see how you combine those, and the properties are very different than what makes them up, okay? And this is what the compound sugar looks like. It makes this six-sided ring, and it's got 6 carbons in it, C6H12O6 we're talking about. So this is glucose here, not really sucrose, which is table sugar. All right, so now with compounds, there are 2 types. This is going to be quite important, actually. This is kind of just barely touching into something that we've mentioned briefly, but not much. And the 2 types are ionic compounds, okay, and sometimes we call those salts, okay. And the key is, and by the way, yeah, in chemistry, when we use the word salts, we're not just talking about table salt. We're really talking about any time a metal and a non-metal are bonded together in an ionic compound. They're held together by an ionic compound, as I mentioned. And the key here is this. You can see right here that this is a classic case. This is just like sodium chloride. The electron is transferred from the metal, which is like sodium, the outside electron. Remember, now I don't have the periodic table in front of me. Let me flip over so you see. Sodium is right here. It only has 1 valence electron. And we know when there's only 1 valence electron, it's got a lot of shielding, and it's not holding on to it very tightly. So that 1 electron is stolen by this atom 2. Now this is a generic form right here, but we can think about this as sodium and this is as chlorine. It could be a lot of other things as well. But the second one here, you'll notice it has 7 electrons. So this is very much like chlorine, which has 7 electrons in its valence shell. Remember, the life goal of an atom is to gain 8 electrons. It's 1 away, very selfish for electrons. It's going to steal 1 from sodium. And then what will happen here is the sodium now becomes positively charged, and the chlorine becomes negatively charged, because sodium has lost an electron. When it loses an electron, it becomes positively charged, okay? When it gains an electron, it becomes negatively charged, because remember, when you start off and it's neutral, they're even. If you lose an electron, the electrons go down. Now the protons, or the positives, are 1 ahead, okay? So it's kind of like saying the positives are 1 up if it was a basketball game or something like that. Whereas on the other side, they gained an electron, so now the negatives are 1 ahead. Oh, the negatives are 1 ahead. And so now, obviously, to be negative overall. You can always tell what the overall charge is by taking the protons minus the electrons, okay? So the key here is this. When they have an ionic bond, you just have 1 atom that becomes positively charged and 1 that becomes negatively charged, and they're now attracted to each other, okay? Now, there are some other features of this that we'll talk about a little bit later, but that's the key idea, is that you have a positively charged ion, a negatively charged ion, they're attracted to each other. Now, the next strategy that we have for gaining a full valence shell is something called a molecular compound and a type of bond that's called a covalent bond. Okay, now a covalent bond means that the electrons, instead of being transferred, they're now shared. Okay, and so what happens here is you have 2. Usually, this comes between non-metals. In fact, let me just make sure I mention that because I think I kind of skipped that part. The ionic compounds are always between a metal and a non-metal. Okay, so the metals are all over here, of course, on the left-hand side, with the exception of hydrogen. Non-metals are over here on the right-hand side. So when you take a metal, you combine it with a non-metal, and you get an ionic compound. You might ask, what about these ones, the metalloids in between? Well, then they're kind of in between anyway, and so we can talk more about that later. Okay, and then molecular compounds, instead of transferring, you have a non-metal and a non-metal, and what they decide to do is they decide to share electrons rather than transfer. Okay, so you've got, you essentially have a deal here where this might be two fluorine atoms or something like that. It doesn't really matter what they are, but it could be two atoms from this last halogens group. And you can see they're both one away from filling their valence shell. And they're both very, very selfish for electrons, and so they might try to pull one away from each other. They can't, and so they decide, probably begrudgingly, let's just share, okay? And that's exactly what they do. They share. Now, they've both filled their valence shell, okay? Because when you share, you can count each of those electrons kind of for both atoms. So you can count around this one. It's got 1, 2, 3, 4, 5, 6, 7, 8. This one has 1, 2, 3, 4, 5, 6, 7, 8. They both now have a full valence shell. So you've got two approaches: ionic compounds, where the electron is transferred; molecular compounds, where the electrons are shared. And this is generally, when we talk about a bond, we're usually talking about a covalent bond. Okay, so we've got three options here. You might pause and ask whether these are covalent or covalent bonds, like a molecule or an ionic compound. And the first one is going to represent an ionic compound. Oh, I see the error. I was like, it said up here, it said, what's wrong with the slide? And I didn't know what it was. Now I see what it was. Okay, so there is one error here. But first of all, let's first decide if these are ionic or a molecule. When we say molecule, we're talking about molecular compounds, which means they have covalent bonds. The first one here, this is obviously representing an ionic compound because an electron is being transferred. This one, H2O, these are representing bonds. Okay, water is an example of two nonmetals, and nonmetals always form covalent bonds. And over here, we have CH4, which is called methane. This is what you burn in your stove, and that's also covalent because hydrogen and carbon are both nonmetals. Nonmetals bonded together form molecules. Now, hopefully you figured out what was wrong with the slide. They made an error right here. This should have been Na positive because sodium loses an electron. When it loses an electron, the positives will now be ahead and it will be Na positive, or sodium with a positive charge. Okay, now what I want you to do is determine if each of the following is an ionic compound or a molecule. It's a good idea, let me see if I can move my head out of the way, but it's a good idea to look down here at this periodic table. And remember that ionic compounds are between a metal and a nonmetal. Okay, and then molecules or covalent compounds are between a nonmetal and a nonmetal, or sometimes between a metalloid and a nonmetal. Okay, and so go ahead and look through these and see if you can tell which ones are compounds and which ones are molecules. I'm going to have you answer each of these, except for the last one. I'm just going to show you this because this might confuse you. But everyone else, 1, 2, and 3, I'm going to have you answer, and then we'll come back and I'll tell you what I got on those. Okay, hopefully you had a chance to answer each of those. The first one then is magnesium chloride. Magnesium is a metal, chloride is so magnesium is right here, chlorine is right here. Therefore, that is a metal and a nonmetal. That is a ionic bond. C and O, carbon monoxide, that's the stuff that can poison you because it looks like oxygen and can combine with your red blood cells. Carbon is right here, oxygen is right here. Both of them are nonmetals. That is a covalent bond. That is a molecule. Carbon and hydrogen. Hydrogen is a nonmetal, even though it's over here. Carbon, of course, is right here. Carbon and hydrogen, that is methane. That is a nonmetal, and a nonmetal, that is a covalent compound. Now, the one that's a little funny is the one down here because it's silver combined with two different nonmetals, okay? But this is considered to be a ionic compound. Anytime you have a metal in it, just as a little hint, if you've got a metal in it, you're going to be talking about an ionic bond or an ionic compound because, of course, silver is the first one, which is right here. NO3 negative is a unique case where you have three different nonmetals that are bonded together, but overall they have a negative charge. Okay, and we'll talk more about that. It's called a polyatomic ion. Don't worry about that word yet. We'll talk about that just a little bit later. Okay, so how do we write a compound or a formula for a compound? This is something that you've already seen quite a bit, so it's probably not shocking or anything like that. But we'll go through it in a little bit more systematic detail. So first of all, the subscripts are the small numbers below to determine the number of atoms. So if you look at this chemical formula, let me put my head down here now. You look at this chemical formula, you've got sodium with a little 2, sulfur with nothing next to it, oxygen with a 4 next to it, okay? The subscripts tell you how many sodium atoms you have. So you got 2 sodium atoms. Now, as you know by now, chemists are lazy. They don't like to write any more than they have. So their thinking is, if it's a 1, I shouldn't write a 1 because obviously I would have never written the S if there wasn't at least 1. So when there's nothing there, that means 1. And then, of course, 4 means 4, okay? Now, the superscripts are when we have numbers up above. We only write these when we're writing just the ions separately, not when we write it together as a compound. And the superscripts always just tell you the charge. Okay, so the superscripts are up here. And then the coefficient is a big number that comes in front. Okay, the coefficient, let me actually take a little picture of this because it's helpful here. The coefficient is a little bit like, it's a little bit like if you were to put parentheses around the whole thing. Okay, let me see if I can switch this. Something's not working with my switch here. Hold on 1 second here. Okay, so if we were to put this, when we've got the big 5 out here, okay, what this means is this 5 applies to everything. Okay, so we've got like 5 of this entire group. Okay, so 5 things. That's like 5 cakes. And you're like, oh, well, a cake contains 2 eggs and 3 cups of flour and 7 scoops of sugar and all of these different things. And when we say we've got 5 cakes, that means we've got 5 of everything. And so in this case, you can think about that. If we've got 5 of this entire compound, that means that we've got now, let's say we had 2 aluminums in each of the units there. And now we multiply that by 5. That means we've got 10 aluminums. Okay, and then over here, this means SO4. We had 4 oxygens here, 1 sulfur. But look at this. We had 3 of this entire group, okay? So how many sulfurs do we have now? Well, we've got 3 sulfurs multiplied by 5 total, compounds. That would make a total of 15. And the oxygens, the total number of oxygens in this whole group, it would be 4 times by 3 is 12, times by 5, we'd have 60 oxygens, okay? So you'll want to practice that a little bit. It'll take a little time, but you'll get that down, okay? So finally, and that is something just to note here, that superscript down there, that superscript right here, I'm sorry, the subscript right here, that will refer to everything in this parentheses. You'll have 3 of those. All right, my lights went out there for just a second, so on to the next one. Okay, so now I want you on this slide to practice some counting, okay, and I'm going to take a photo of this so we can pull it off to the side. Okay, so I've pulled this over here and I actually kind of started on it. You can kind of see here, but let me erase. Well, you guys can see what I did. So anyway, I'm going to do the second one here where it says how many molecules or compounds. So you can see here that the 3 here tells us we've got 3 molecules or compounds. In this case, we've got 3 molecules. That's what the big 3 means. The next question is how many atoms in 1 molecule or compound? Okay, so if we look at this, carbons in the actual 1 molecule, we have just 1 carbon because there's only you can imagine there being a 1 there. Hydrogens, we have 4, and then over here we have the total in all the molecules or compounds. Remember we had 1 carbon in 1, but we've got 3 molecules, so we must have 3, and then we've got 4 hydrogens, and again we have 3 of those compounds, and we must have 12. So that's how you do that, okay? So what I want you to do is I am going to ask you a couple of questions about this, and then what I'll do is I'll go through and finish this. I'm going to pause for a second. You work through the rest of these, and I'll actually get back to this screen here so you can look at, my screen's not coming up very easily. Here's the screen, so go ahead and look at it as I ask a couple of questions about it. Then I'll go back to the other one, and we'll finish this chart so you can get that down in your notes. Okay, I'm going to go through this kind of quickly here. So we have just 1 molecule here, 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen. Down here we have a total of 4 molecules. We have in 1 molecule, we have 2 nitrogens, 1 oxygen. We have 8 nitrogens and 4 oxygens here. Now this one's a little bit trickier. We've got 2 overall compounds. In 1 compound, we have 1 magnesium. In 1 compound, we have, notice, we've got 1 nitrogen, but you've got this brackets around this part, indicating that there are 2 of this little grouping here. So that means in that part right there, we've got 2 nitrogens and 6 oxygens. So this little 2 here has to apply to this whole little group right here, okay? But now we've got 2 of this overall compound, 2 of that whole compound, And so therefore, in this answer, we're going to have 2 here. We're going to have, instead of just 2 nitrogens, now we've got 4 because we've got 2 of those compounds overall. And instead of 6 oxygens, now we have 12. All right, for some reason this is not switching easily. Okay. All right, so now we are at the final little video at the end. What I want you to do, I'll have just a question at the end that's just kind of a review question, but hopefully that helped you get through your notes today. We are going to have one other video that you'll watch, maybe that will give you a little bit more of a smoother overlook at some of these concepts, but I think this is something you can get down really solidly and probably won't be overly confusing, except for maybe a few little questions here and there on how to make sure that you're getting the right counting. All right, have a great day.